So today I'm going to briefly go through the lessons 1.1 to 1.3, which are covered on page 25 in your textbook. So the first set of, let me move this out of the way a little bit. The first set of problems involves patterns. And so, let me get a good pointer up here. And so this particular pattern says draw the next figure in the pattern. So notice that the very first picture is one triangle, and then the second picture are two triangles. So we go from one triangle to two, now three, and now 1, 2, 3, 4. So numerically, I'm having trouble with my stylus reading my program here. But anyway, we have one triangle here, two here, three here, and then 4 here. All right, so then our next figure must have 5 triangles. So 5 triangles here. And so let me switch my color. So maybe we would have, there's one. I must have a really terrible stylus. And then there's a second triangle, and then a third triangle, and then a fourth triangle. And now how about a fifth triangle? So it's ugly, but there you go. There's your pattern of your fifth triangle. For this next grouping of problems here, you're going to have to look at the pattern that's occurring and then find the next number in that pattern. So I'm only going to do one of these with you. And typically you're looking for a combination of addition, subtraction, multiplication, or division, or maybe just a pattern where maybe it's like all odd numbers, or the Fibonacci sequence, if you know what that happens to be, or just something like that. So some of them can be a little tricky. So I'm going to do number 3. And the one that kind of doesn't seem to make sense is this 2x over 3. So kind of ignore that right now, but look at the x over 3, x over 6, and x over 12. So in the numerator, the x is not changing. We originally had a 2x, and all of a sudden it became an x all the time. But then notice what's happening between 3 and 6 and 6 and 12. The only way to go from 3 to 6 is either to add 3 or to multiply by 2. The only way to go from 6 to 12 is either to add 6 or multiply by 2. So the one thing that these have in common is to multiply by 2. So it looks like the pattern would be to multiply. If I can get my stylus to work. It just doesn't want to cooperate. I have to get a new one. It's really squishy. And then what if I multiply by 1/2? There we go. To get to the next one. So if I took x over 12 and multiplied by 1/2, wouldn't I have x times 1 is x and 12 times 2 is 24? So then the next item in that sequence is going to be x over 24. That's a 24. I have the world's worst stylus. Now, how does that work with 2x over 3? Well, notice that if I multiply 2x over 3 by 1/2, notice that the 2's cancel, and you're left with just an x in the numerator and a 3 in the denominator, which gets you to x over 3. So the pattern is multiplying by 1/2, and the next number in the sequence is x over 24. So now you try 2, 4, and 5. This next group of questions deals with the properties of real numbers, which we went over last week. So take out your notes from last week and your homework from last week, and you have an entire list of properties. And so I'm just going to do number 6 with you. If we go from 7 times x minus y to 7x minus 7y, we must have distributed that 7. So this would be the distributive property. promise you I'm going to get a better stylus come tomorrow. This one's terrible. So that's what this one is the distributive property. So you do 7, 8, and 9. So this next group of questions, you're writing algebraic expressions. You're translating from words into algebra. So I will do number 10 with you. So 8 times, and then it's multiplying. It's 8 times what follows times the sum of A and B. So it should look like 8, and then times in parentheses the sum of A plus B would have to be in parentheses. So now you do 11 through 13. This next group of expressions, you're just simplifying. So if you have something to distribute, you'll distribute that first. Notice that there are no equal signs here. So you're not going to come up with, x equals 2. You're just simplifying, collecting like terms. So I am going to do number 15. So let me circle that because that's the one that I'm doing. And then you'll do 14, 16, and 17. So I'm going to start off by distributing the 2 and then the 5. So off to the side, I'm going to do the work. So negative 2 times D is negative 2D. And negative 2 times positive 2E is a negative 4E. And then distributing the 5 times 3D is a positive 15D. And 5 times negative 8 is a negative 40E. So then my like terms, I have a D term here and a D term there, and then the E's will be combined together as well. So if I have negative 2D's and I add positive 15, a negative 2 and a positive 15 is a positive 13. So I get 13D. And then a negative 4E and a negative 40E, same sign, I'm going to add and keep the sign. I get a negative 44E. And then that's it. That's simplifying as far as I can go. You do the other 3. So for this group of questions, I'm going to do number 18, and you want to set up a table. And so this is your X and this is your Y. And so our first X, if you look at this ordered pair right here, this has to be 1. And let's just assume that halfway in between here, because that's 1 there, is a half. So I'm going to say 0.5. I'll use decimals in this case. So our X value is 1 and our Y value is 0.5. I'm just going to start out by putting my inputs and my outputs. So X is my input, Y is my output. Then the next input is 2 for X and then 1.5 for Y. And then my next input is 3 for X and 2.5 for Y. And then my next input is 4 for X, 3.5 for Y. Kind of see a pattern on this particular one. And then 5 for X, 4.5 for Y. And then finally 6 for X and then 5.5 for Y. Okay, so then we have to figure out what are we doing to 1 to get to 0.5. We could subtract 0.5 to get to 0.5. We could take 1 and divide it by 2 to get to 0.5. So let's see what happens here. If I take 2 and I subtract 0.5, do I get 1.5? Yes. 3 minus 0.5, 2.5, so that must be what's happening. So what they mean by the process column, so this is your process column, is you're just taking 1 and subtracting 0.5. You're trying to look to see what is it that you're doing each time, what's the pattern. So 2 minus 0.5, so your 0.5 is the pattern, you're your minus 0.5, and then 3, and then 4. So I'm going to tell you that the problem that you're going to do, 19, is not just a simple subtraction. Okay, so then the pattern that you're identifying is, in words, it would be subtracting 0.5 or algebraically subtracting 0.5. So that's your pattern, if you will. And it's really your, and I guess let's do it this way, it'd be a little bit clearer. So let's go ahead and take for your pattern, you would take to get your output would equal your input value, whatever that is, minus 0.5, or in that case, our case, we used x and y, so y would equal x minus 0.5. So I would accept either one of these as your pattern. So for this next group of questions, when you evaluate given values for variables, you need to use substitution parentheses. So I'm going to do the easiest one first. So I'm going to do number 20, and I'm going to substitute in only for the A and only for the B. So then I'm going to do my workout here. So I have 7 parentheses minus 5 parentheses. And instead of A, they told us that A was 4. And instead of B, they said B was negative 3. So you're just going to do the math. 7 times 4 is 28. And then negative 5 times negative 3 is a positive 15. And then you get 43 as your final answer. And then you do the rest of those. So in this section, you're going to do essentially half of a word problem because they haven't given you enough information to actually solve the word problem. So I'm going to do 23 with you, and then you'll do 24 on your own. So essentially, I like to do my word problems in 4 parts. The first, and you're only going to do the first 2. So this first part, you are going to define your variables. See if I can write on here without messing things up. So you need to define your variables. And so here it says, you have 16 tomatoes and your tomato plants produce 5 tomatoes each day. So the thing that causes you to get new tomatoes would be the passing of a day. So if you knew how many days had occurred, you would be able to figure out how many tomatoes in total that you have. So I'm going to let D equal number of days. So you do have to define that variable. And then the second part is to write an equation to solve, or in our case, it's going to be an expression. So over here is going to be your equation to solve. But because we don't have anything for an equal sign, we're just going to do an expression. So you have 16 tomatoes, and your tomato plants produce 5 tomatoes each day. 5 tomatoes each day is 5 tomatoes per day, 5 tomatoes times each day. So won't that look like 16 tomatoes plus, you're going to add to that 5 tomatoes every day. And so that's it. You can't go any further. We don't have an equal sign. You do number 24, and please text me with any questions.